Our company is involved in the manufacture of making dry ice. So the equipment that's used to take liquid and converting it into solid. Most of that dry ice is used for transport cooling, but a good portion of it is used to blast. We also make the capital equipment that's used to blast that dry ice in order to use a media that is dry and non-abrasive and no secondary waste. So it's a great way to clean things. Dry ice equipment, all the equipment used to dry ice goes into the machine and you load it. Kinetic energy is doing a lot of the work, and you control the kinetic energy with that particle size. You either leave it at 3 millimeter that's supplied or a block, or you start to cut it down. So you control the kinetic energy. That's cold, so you get the little thermal expansion and contraction between dissimilar materials. You can embrittle a contaminant, which we'll talk about what those are. And then it just sublimates it, it grows inside. In the composites industry, this is used because the contaminants are a variety of contaminants, from sacrificial mold release agents, whether they're water-based or solvent-based, to the actual product itself, the resins that's found on the tooling. You've got to get those off. Traditionally, you clean it with a scraper, with a razor blade. It's an abrasive way to clean tooling, and you're damaging a very limited and precious asset. This is a non-abrasive way to clean it. So we're cleaning that. The substrates themselves in the composites industry is a very broad spectrum. Sometimes they're made out of composite resins themselves, sometimes they're aluminum, sometimes they're steel, sometimes there are so many different substrates, so many different contaminants that dry ice allows you to adapt to that variety by controlling that kinetic energy. 1/2 mass, velocity squared, that kinetic energy, you control the size of the particle we talked about, you control the pressure, you adapt the process to your contaminant and your substrate. So that's the beauty of it.